right, everybody, it is 1 o'clock Eastern time, 11 a.m. Mountain time. So we are going to go ahead and get started here. Again, sorry for if you've been sitting on the line for a while watching us twiddle our thumbs. I started fiddling with the settings for the Zoom webinar about 5 minutes before we were supposed to start, which is not a smart thing to do, and I accidentally started the webinar. So here we are. Anyway, today's Atomic Friday is kind of a little bit different than a lot of the ones we've done in the past. By way of introduction, I'm Brian Donahue. I'm on the community team at Red Canary. I help produce a lot of our content. I do a decent amount of work with Atomic Red Team. So by and large, I talk and I write things about computer security. I'm joined here today by Brandon Denker and Mike Mitchell of Cyborg Security, and they've been using Atomic Red Team in some pretty interesting ways. Like primarily, they've been building a threat hunting platform, but some of the stuff they're going to talk about today involves test simulations they've been developing on top of Atomic Red Team, sort of on top of Invoke Atomic to be more specific, that are designed to emulate like some of the top commodity malware. And I'll hand it off to them in a minute, and they'll surely do a much better job describing who they are and what they do than what I just did. But before I do that, I just want to say that I want to encourage everyone to comment and ask questions, but I'd ask that you do it in the Atomic Red Team Slack channel rather than in the native chat app here. So if you're not currently in that Slack channel, let me go ahead and post a link to it here. So if you're not in there, go ahead and join the Atomic Red Team Slack channel, and we can have a conversation over there while we are going through this presentation. So let me hand it off to Mike and Brandon, and they can tell you what they're going to tell you.
How's it going, everybody? So I'm Mike Mitchell, so co-founder and VP of Engineering for Cyborg Security. And so we're going to tell a little bit about ourselves first, to kind of set the stage and frame why we chose Atomic Red Team, and built that into a lot of our process. So I have about 8 to 9 years of cybersecurity experience. Started out as lead engineer for a company called Foreground Security. Then I had the opportunity to join a startup very early on in the source space, working as a sales engineer and a director of sales engineering. And then Brandon, you want to speak a little bit about yourself?
Certainly. So my name is Brandon Denker. I'm the Director of Research and Threat Intelligence for Cyborg Security. I've been doing cyber for about 13 years for Department of Defense, Department of Energy, kind of bounce around just about all different facets of malware RE, pen testing, packet analysis, pretty much you name it. So I lead up all of our content development efforts and a lot of the Atomic Red Team stuff here.
Great, thanks. So this is just an overview. We're going to talk a little bit about us. I'll keep it short and sweet so we can get to the demo. I want to kind of frame, again, the challenges around threat hunting from a business and a technical perspective. And then again, like I said, we'll dive into the Atomic Red Teams that we're creating and jump into the demo with Brandon. So who are we? Who's Cyborg? So we're made up of a group of advanced threat hunters, analysts, and engineers. A lot of us came from that company called Foreground Security that I mentioned earlier. That company was a managed service provider, ran over 20 virtual security operations centers. And in that, we gave our first talk about threat hunting at the G1st 2011 conference. And so we really started to develop awareness around threat hunting and kind of stamp that into the general SOC process that is talked about today. So after Foreground was acquired by Raytheon, a lot of us went our own separate ways. Brandon and some other team members went and built threat hunting and threat intelligence operations at other companies. We all tried to get back together, got the gang back together, so to speak, to really figure out a solution around threat hunting and create and kind of pioneer a new thought method around how we can deliver threat hunting to customers and organizations. So again, to frame again why Atomic is so important to us, there are a lot of challenges in threat hunting. As everybody knows, finding, retaining, building those set of skills from an analyst, maybe a tier 1 up to a tier 3, building those threat hunting skills is hard to do, right? Everybody talks about alert fatigue. Most analysts are reactive instead of being proactive. Again, threat hunting should be a very proactive type of task. And then understanding how to really get that return on investment from a threat hunting perspective, right? So it takes typically 1 to 5 FTEs to build a threat hunting team, anything from differ to threat intelligence to analysts, those type of roles to really culminate a complete threat hunting team, right? And then, in our industry today, there's a lot of talk about AI and machine learning. Those things are great for anomaly, statistical analysis, those type of detections, but it still takes a human's intuition, knowledge, and experience to build a threat hunting process and a model. And then we get into the actual technical challenges. So visibility is key, right? What type of data do you have in your environment? Is that going to allow you to do the type of advanced threat hunts that you should be able to do? And then prioritization, right? We talked about alert fatigue again. If you don't have time to do the threat hunt process, to do the research, run through those methodologies about testing, deploying, the documentation, right? That takes a lot of time and effort. And a lot of times, if we're reacting to alerts, you might not have the time to do those type of threat hunting tasks. And then there's a lot of open source based solutions out there right now, but there is an increased time to deploy to take that content and deploy it in your environment. And so I'll speak to kind of our automated assisted mapping process that really allows you to take your source types, your indices, and your fields, and the content that we export, it's mapped to those unique environment configurations. So out of the box, you can run it. It should work without any type of configuration changes needed. So again, I'm going to try to fly through this so we can get to the demo. Cyborg as a solution. So we're a threat hunting platform. We provide contextualized and rich use cases that provide threat hunting content in what we call threat hunt and detection packages. We also provide a focused threat feed. So the threat hunt and detection package really contains the contextualization, everything A to Z that you need to know how to deploy a full threat hunt. And we provide that in that platform, right? So an analyst can go do the research, as we talk about the 3 tenets at the bottom here, explore, right? You're able to search against MITRE, kill chain, any other tagging that applies to your environment. When you deploy that content, again, it's already mapped to your unique environment, so you can run it right out of the box. And then we get into the hunt process, right? So being able to understand the best practice recommendations, any mitigations, our analyst notes, potentially additional queries and playbooks that allow you to rerun, scale, and repeat that structured process. That is threat hunting. All right, so now the good stuff. Validation is key. So very early on, as we were developing this content, we recognized that, while you can trust that we're making amazing content, you need to verify that that's going to run in your environment. And so we recognize that Atomic Red Team, those red tests that they're creating, are crucial in the deployment process, right? The analyst needs to understand that rule is configured properly. They need to understand what that detection might look like if it fires in their SIM, Splunk, Elastic, QRadar, whatever SIM they're using, right? It's good to understand what data is actually going to come back and then how to use that in the next steps. And then it also enables engineers to, again, test, validate that those threat hunt and detection packages were deployed properly. And so we decided to build Atomic Red Team tests into every single threat hunt and detection package that we deploy. So that gives you the ability not only to deploy the full threat hunt, but also to validate that threat hunt has been configured properly. Right? And so understanding community is very important to us. Every test that we create, we're gonna make publicly available. We're working through a process right now with Red Canary's engineering team to be able to submit those tests back into their repo. And as Brandon will mention here in a second, we've built some additional complexity and usability on top of Invoke to allow us to chain attacks together. And I'll let Brandon speak to most of the the technical details in the demo of what we're going to show today.
Awesome, thanks. So let me steal your screen.
Absolutely.
And let's see. All right. Great. So, as Mike mentioned, the validation is one of the biggest proponents. We're one of our biggest proponents of all of this is validation. You can trust your vendors all you want, trust open source things that such, your buddies, but sim tools as well as just other tools that you utilize within your environment are complex, right? We know sometimes logs don't appear the way we expect. They don't get indexed the way we expect. One of the things that we actually ran into quite often was when we would execute a piece of malware in a lab environment, or we'd start even trying to develop some of these tests. We would have a string, call it 4,000, 5,000 characters, and when that gets logged to a specific field, the sim reacts a little bit differently in some cases, depending on how that field is indexed. And then that affects how it's searchable. So, the expectation is of course it will work. We've tested as much as we possibly can, but there's certainly outliers, and this is a good way. The framework already exists here with Atomic Red Team to get those validations in, ship them with deployment steps, additional validation steps. Atomic Red Team does have the ability to just write out manual steps, and it just gives you a good list of here's some of the things you have to do. So it made sense. It was a great framework to work with. And what we did was we wanted to focus more on the analytical side of things, where it's great if a rule can trigger, or maybe a hunt can be verified in some way, shape, or form. But it's even better if we can show you what that traffic looks like in your logs. One of the probably top 5 complaints that I've heard from analysts in the past and through my various different jobs is I don't know what I'm looking for. Even when a rule triggers, I'm not quite sure what that activity is supposed to look like, or without going through a lot of steps to go to a website or like the vendor's website to go look up the rule or go ask questions and hope to find it on a forum somewhere. So we really wanted to try and make it look like as close as possible without obviously making it malicious to the real thing. So that's where emulation kind of comes in. We're taking real world modified activities, trying to push them to a specific threat type, and we're utilizing Atomic Red Team's framework to input different parameters, because the test may already exist, but it may need just slightly different file name that's only specific to this particular malware. I mean, you take like Azerolt, a lot of times regasm is a good indicator of it being on a box with a different hash. So some of those kinds of things that really help an analyst understand, okay, this triggered, this is the kind of activity. You can run your own little examples around it. It makes life a lot easier for an analyst to understand what's going on, as well as validate, triple, quadruple validate, change slight small characters. One of the things that we ran into actually here recently was, although malware utilized a lowercase character forever, randomly they changed and started using an uppercase, and it broke one of our hunts because we hadn't factored that in. So it's little things like that to validate that we're making sure we're getting it all there.
Hey, Brandon, I have a question for you that has absolutely nothing to do with the topic we're talking about. Do you by chance have an oscillating fan running in your background?
Yes, I do. And
can you turn that off?
Certainly.
Sorry, it's
like no worries. Yeah.
Couple of seconds, it's sweeping across your microphone. All right, sorry about that. You can carry on.
No worries, absolutely. Yeah, it's become second nature. I don't even notice it's there anymore. Yeah, so we'll jump right into the demo. I mean, so we have 2 demos lined up. We're going to try and get through both of them. The first one I think is the most interesting, so that's where we'll start. The second one, we kind of dig into the inner workings of what we've developed in terms of changing kind of the way that we're using Atomic Red Team versus the standard way. So what we'll kind of go through in the first demo is we'll go in and we'll install atomic red team tests. We'll install Cyborg specific ones. So if you're not familiar with atomic red team, no worries. I'll go through kind of the steps of getting it installed on your system and making sure everything's there. And then we created 3 variations for testing Emote specifically. We've done an email with a maldoc separately, and then just a straight up encoded PowerShell command that emulates one of their commands. And we'll do an elastic signal validation, as well as we'll kind of show you what that looks like in Kibana when you run that query as a hunt. So we'll go ahead and just dive right in.
Can you elaborate on why specifically you chose Emote, like among all the many commodity threats you guys could have started with?
Absolutely. Emotet's pretty high on the visibility radar right now. They do have their hiatuses in between, but that's the main reason is when we've talked to a lot of people, as soon as we kind of mention the word Emote, they immediately can go, yep, okay, heard that, seen that. Azerold, NJRAT, some of those other ones, a lot of people necessarily haven't heard, especially when you start talking about all the way through the chain, right? Is, most of the people up in the executive level have probably heard it because they've either been affected by it or they've read some articles about it. So it's a little bit more universal is one of the reasons why we tend to push the needle towards Emote, just because it's pretty common.
As like a follow-on question to that, have you put any thought to like chaining multiple chains together? So like historically Emote drops into an environment, drops trickbot moves around, steals credentials, and once it's like thoroughly compromised the environment, it drops Ryuk. Now I don't think we're seeing as much of that as we did maybe last year, but have you guys put any thought to maybe like chaining those 3 tests together so that you get like this full, front to back of what an Emote campaign would look like potentially in an environment?
Absolutely. So like Quackbot is one of the ones that's being dropped at this moment. So as soon as we have some of those tests available, then yeah, the thought process is that everything we've kind of created is meant to be run on top of each other. So we could run a Emote test, say we want to run the PowerShell encoded, just the encoding for some reason, and then we wanted to kick off, Quackbot C2 or malware payload download, whatever the case may be. Certainly that's on our radar. Right now, we don't have a lot of the ones that are dropped by each other yet. So we have like, NJRAT, Emote, and a few other big malwares that we're seeing right now. And as we build that out, we will start chaining those together as well. It's a great question. So let's see. So if we take a look, so we have PowerShell open as an administrator within one of our lab environments, and this information will be up on our GitHub, but it's pretty much as simple as running just 4 commands. There is some ease of use in terms of every time you open PowerShell, that's going to make me copy that. Every time you open up PowerShell, you do want the invoke module ready to go, and we will have that information up for you as well. I can actually show you while this installs. So what I just ran is the first one, it gets the install atomic red module for PowerShell. The second one that we're seeing here is it's installing atomic red team, and we're getting the atomics. So it's downloading all of those atomics into a particular folder. By default, it goes into your C drive atomic red team /atomics. And the reason we have the force flag is we already have some of our stuff downloaded here, and we want to override it with whatever's new. If you don't want that, then obviously you're not going to want to put that there. But if we run another super secure password for our lab. So this is kind of something that we want to set this because some of our tests may may fail, or they don't want, they cry about the execution policy. But basically, if you throw some of this stuff into your profile, then Atomic Red Team will always be available. You won't have to run this every single time to get the module going in your profile. Again, that's kind of the stuff that we'll put on our GitHub as a quick and dirty of how you can get Atomic installed on your system.
Yeah, we've also got tutorial videos that cover this, and the Invoke wiki has information on this as well.
Absolutely. Yep. Give it a few more seconds here. So we'll go ahead and copy our next one. So the next one is a module to install a particular folder. So we'll go ahead and run that one. And this is how we can get, yes, thank you. It's overwriting some of the things I have open, so bear with me. All right, so this one's actually going to reach out to Cyborg Security's GitHub page, and it's going to install from the branch Cyborg, and it's going to install it to C Atomic Red Team Cyborg, and then Atomics. So the idea here is we have our own set, but a lot of our Atomics actually rely on, so I can give an example here. For instance, our Atomic will actually rely on the regular Atomic Red Team being present. We can also make it so it can run it from its own, like the Cyborg directory as well. But the biggest thing that we're trying to do is we're not trying to reinvent the wheel. We want to run an Atomic that already exists with just some different inputs, which I'll get into here in a minute. Just waiting for that to install so we can start to have some fun.
Yeah, so is that, I'm getting ahead of ourselves, but we're sitting here waiting anyway. Is the Inputargs how you guys have modified Invoke Atomic to run your tests on top of it?
Yes. So the idea here is we can go look up. So like this one is looking for 1562.004, which I have up here. And if we come down, it's looking for a test here, and we look for just what where it is, input arguments. We look for what the input arguments are. And as long as the command that is actually run, if we look down here, the netsh, for instance, if it looks similar to, or it's good enough for what we need to run, we'll just change the input arguments. If the command, like we need to add something to it, it doesn't have a certain flag that is really needs to be there given based on the malware or actor, we will update. We will actually commit a new Atomic test to that YAML file, and then still run it from our, we call it emulation side of things, where we're actually naming things, NJRAT versus a TTP ID.
Yeah, that's super interesting. I wonder if Matt or Carrie or Mike or any of the other maintainers or any of the people who worked on developing Invoke had that use case in mind when they built in the input custom arguments feature.
Not sure. We're
feel free to answer.
With that team. Yeah, we're working with that team to certainly find the best way to do that kind of chaining and call those things. Because there are a few nuances, and like I said, I'll kind of get to some of those nuances that you kind of have to deal with when you're calling an atomic from an atomic from an atomic from an atomic kind of a thing, going down that rabbit hole. So first one, like I said, we're going to do Emote. So we'll go ahead and look for Emote. Because what this will do is this will just list the available atomics we have for our package for Emote. So we have 3 tests that we can run. So we'll kind of just run the most simple one to start with. And it's really easy. So if you want to look at the actual details of all of the tests, you can say show details, and you actually we can see here, this is a cleanup command. So if we scroll up, So this is the one we're about to run, the encoded commands. As you can see here, we're just running a default, 1027, this particular test within that, and then we're adding specific input args. So the idea here is, again, we're not trying to reinvent and write a bunch of Emote test specific things and then commit those to the original tree. The idea is we're trying to use those and then just modify, like, this is the actual PowerShell command we want to run, right? So this is a little bit more of what we would expect Emote to run. And if we want to run that, let's go ahead and do test names. Oops. Paste that guy in there. And we go. It'll go ahead and execute it. It'll spit out the end result PowerShell, and it'll actually execute the PowerShell command. So we can see here that it launched a file name from our local temp. And in this particular case, we didn't. This is the kind of the state where we would have something more as we start to chain more of these together. Right now, it's just a simple public IP check. Yes, I can access the internet check. It's nothing too sophisticated as we start out. But the idea is we'll eventually start adding more of those in as we go along. So that one ran, and then we can see if we go to our event viewer here and click refresh, and we'll go down a few. There we go. So you can see here, this is the log that we're actually interested in, where we have PowerShell and it's launched that big long encoded command. So we can go to the sim and see and make sure we actually got that data and it triggered or it works for our hunt of how we're looking for it or any of that sort. So that's the first one. The second one I think is pretty cool. We were able to utilize a lot of the work that Atomic Red Team has already put in, and they created a really cool invoke maldoc PowerShell script that we're going to utilize for this second one. So this one we're actually chaining together where we're creating a maldoc. So fortunately the script supports Excel or Word. We're just going to go create a Word document, inject a macro, and then execute that macro, which is our malicious PowerShell.
Hey, I actually have a question before you do that. This came in from DFIR Jess in the Atomic Red Team channel. I'm going to read it verbatim because I'm not 100% sure what's being asked.
Sure.
But it says, can you go down one more event ID to where it should decode the 64 encoded payload in Event Viewer?
So in Event Viewer, I've never seen it actually decode it within. Let me find that.
You used a different tool to do it when we were doing this a few days ago, right?
Well, yeah. So you can actually copy paste this into, like I use CyberChef is our biggest one. So we can go to here. So we'll go ahead and take a look at our trigger that we have within Elastic. And when we expand this, so we got it from our Windows security events as well as our sysmon events, which is good. It means it works. So we will expand that to go down and get that. So we'll copy. Oops. Control B. Get rid of this garbage here at the front. And then we can see what the output was. So this matches what we had in our input arguments. The only thing that we really changed from this in comparison to where like the actual malware sample we grabbed it from is we changed our URLs where it gets it from, which are still in plain text when you actually decode this, to just some benign things, and then eventually reaches out to the last one, which actually grabs that benign executable.
Awesome. We've kicked off a riveting discussion in the Atomic Red Team channel about where this will be decoded, whether it's script block logs or PowerShell logs.
In PowerShell logs, it'll probably show as decoded, but in Event Viewer, it just shows the literal representation of what was run.
Awesome.
So yeah, so we have two more tests. This one, like I said, I think is pretty cool. So it will create on the fly. So every time you run this, it will create a Microsoft Word document. It will create a macro within that document and then execute that macro without you ever having to open Word or click, enable content or anything like that. So it happens all in the background without any user interaction, which is really nice in terms of, the user running this test, not having to go click on 5 or 6 different things to make it run. So now that's run, we will go ahead and come back in here real quick into our event viewer, and we can see, let me get to the Word part. So here we can see we have WinWord launched PowerShell, and it launched this command. And then we will see PowerShell open and then execute this this name. And these names are very much intentional. So actually up until like last week, Emote was very well known for just using either a complete name, like human readable name, or numbers like 168, 192, 148, things like that. And just recently they changed that. So we went ahead and changed our naming structure. So each one of these tests generates a different name. And as they update those, we'll update those as well. So that way it's kind of leading edge and make sure that you're analyzing, you're looking at something that has actually occurred or is occurring.
Hey, we got another question that I think I know the answer to, but I'm going to ask it anyway. Do you have to have Word installed for these tests to work?
Yes. So that's actually a great point. That's something that I was going to get to in a little bit, but there's something prereqs. Oh, check. So this is something that is what it'll do is it'll actually check and make sure you have everything installed. So the answer is yes, you need Word installed to run these tests. And this last one where we have to generate an email, you'll need Outlook installed. So that's a test that we're running. If they're, as we push these to the community and we get more feedback, if there's other clients, if there's other applications that they want, that we see being used or that they want to be able to test in, absolutely, we will check those out. But you can run the prereq command. And what the prereq will do is we have a few requirements to say we need Office installed or we need PowerShell version whatever. And those are actually defined within the YAML structure itself. Like if we come into NJRAT, one of the ones was, NetSH has to be available. So it just does a quick check using the prereqs. Since we're chaining these together, it uses the original prereqs that are written for it to check whether it actually is there. And then you can also use a get prereqs for like a file or an application that isn't installed. Obviously, we can't necessarily install Windows or we can't install Office for you or anything like that, but it works for most of the stuff. And the other thing, while I'm talking about other commands that are really noteworthy, is the cleanup command. So as we go through our development process, we do the best we can to do checks before we run a command to make sure it will execute successfully. This will come into play in the NJRAT example that I have. Is if you run these over and over and over, we might be dropping files to the system, and PowerShell gets a little whiny if you try to overwrite a file that's not there, if you don't have a certain switch enabled or something like that. So the cleanup command will go back and remove as best as possible, because there's sometimes you can't remove everything, back to its original state. So if you dropped a file, if you injected something into the registry, anything like that, we make sure and try to go clean up after ourselves. And you can run that after you've run the original command. So we'll go ahead and run our last example here. So this one will take a little bit because it does a lot. So this is all done on the fly. We're not pulling an email from GitHub or anything like that. So we're generating a brand new email with whatever text is configured. We are generating a Word document, attaching it to that email. Within that Word document is going to be a macro. This is the only thing that we couldn't get around. We have to click on it. Even though I'm an administrator, it still asks for permission. So it does all of this in line so that way you can see someone opening up Word, opening up Outlook, and then shortly after, opening up a Word document that has a macro that runs PowerShell that opens and launches a executable. So you can see a lot more portion of that attack chain.
Hey, Brandon, can you go into a little bit of detail about how you create that email? There was a question that was just asked.
Yeah, absolutely. So if will actually, I don't have it open, so let me go ahead and open up. So we're going to Cyborg, Atomics, Emote. There we go. So for which one we're looking at, that's the maldoc. Scroll down. That's the encoded command. So this must be it. All right. So this is our email. So we're utilizing a slightly modified version, as we can see here, of let's go here, and I can show you what we've actually ended up doing. So we used a slightly modified version of Atomic Red Team's invoke maldoc. We called it docfish. So if we search for Outlook here, just to make life easy. So this is how we're creating the Outlook message. And this is all on our GitHub page. This is publicly available if anyone wants to go take a look at it. Go ahead and minimize that. So these are basically the commands that we're running. So we're creating a new message. We're setting the from, to, subject, body. We're attaching the document, and then we are saving it, closing it. It's actually a very small number of commands to generate that. And then if we want to actually execute all this stuff, so this actually takes input parameters. So you can either just create all this stuff and then go run it yourself, or you can actually execute it if you want to execute it as well as part of the process chain. And this will go through and open up the Outlook using Outlook, open up the attachment from it, and start going down that rabbit hole of executing everything for you. It's a great question, but like I said, that's available on our Atomic Red Team page under the Cyborg tree. So we got that one to launch, so we can go quickly take a look at some of the logs that it generated just to make sure everything came through. So it's before Chrome. So there's Word. So we have Outlook being opened, and then we have Word being opened from that. And as we keep going up, we can see the PowerShell launched from WinWord. And if I go up one more, two more, we can see we have a different file name being executed from PowerShell.
Yeah, I feel like, so this question came in from the chat, but I would ask it myself as well. Why hasn't Outlook launched here?
So Outlook did launch, it launched in the background. So if we run this again and we watch it, so while I was in Chrome, it actually opened up Outlook. We can open up Outlook in two ways. You can open it in invisible mode, but you can also send it to tray. So if you look down here, if you can see my mouse in the bottom right hand in the tray, you'll see the first instance of Outlook being opened, so that way we can generate the message. Okay. So there's Outlook, and we had to quit because you can only have one instance of Outlook open. So what it does is it opens it and then closes it. And as we can see here, specifically for logging, we're trying to provide a little bit of a gap. 30 seconds, this is going to be configurable within the Atomic itself. So if you want to sleep for 5 minutes, because since we did open Outlook, right, that'll show in the logs. Since we did open Word, because we're creating the Word document, some of these things are occurring in the background trying to set all this stuff up. So there's the there's the Outlook or the message that we created. This was taken from a real world example submitted to a sandbox. Same thing with the subject and the sender. Well, except for example.com. We sanitize that. But this is also something that's fully configurable. You can input any language you want into the email message, as well as you can name the document anything you want, the subject anything you want, and that's what I'm going to dig into as part of the second demo, which I'll probably start now because we have about 10 minutes because I want to leave some time for Q&A as well. So,
Hey, Mike, while you're transitioning over, Brandon, can you post the link to the Cyborg GitHub site if it's open? It might be a closed repository. I'm not sure. Someone asked in the Q&A.
Yep, it's open. I'll get it out to the chat right now.
So and this is one of the things where that cleanup command comes into play here. So we actually saved, so you can go look at these. We saved the executable and we saved the message. So if we open this up and we go ahead and paste that guy in there, we can go get that message and then play with it, do whatever we want with it. But this one in particular, we wanted to make sure we save that message so you can look at it and do whatever you want with it. So we can open up the document here. We can see just like a real email. And Emote recently changed their image of what they're using within their Maldoc. And again, this is why we're trying to make it as extensible as possible. So this is just a PNG that we host on our GitHub that it goes out and gets prior to creating the document. So this is fully configurable. You can put in an image from your local host if you want a different image in there, whatever the case may be. That's what we'll dig into right now. So I'll go ahead and get to, and it wants to restart from the front. There we go. And I guess I'll pause for some questions. Anything on the Emote specific stuff before I kind of get into like how we're doing it on the back end?
Someone's typing, but while you're waiting, so are you manually updating that PNG, or is there a way that you guys are able to sort of automate that process?
So it's a manual process at the moment, but it comes as part of our workflow. So as we're doing research for updated use cases, because a lot of times, we have to keep up with what Emote's doing so we can update our content. Because if it changes something, we have to update that too. So we have streams of intel coming in that we process and things like that. And as part of that is output to go, hey, this changed. So, okay, cool, let's go update. Let's go grab that image and update it. Like I said, same thing for like the wording. We probably won't update as often because the wording pretty much stays somewhat consistent. The only use case when we start talking about Emote specifically is obviously we can't duplicate the email chain that someone might be using against you, right? That's something that Emote does is they copy the whole email chain of someone you know. So we can emulate that with some fake people, but yeah.
DFIR just asked if Emote does server message block traversal. I can't quite remember if it uses SMB or not. Do you by chance remember, Brandon?
It does not as its own malware as far as I'm aware. There are droppers and there's other things that it throws onto the system that is capable of that. So Emote is basically the delivery engine. It's SaaS basically. So anyone can go out and find, hire them to go, hey, I want to drop XYZ, right? And then once that's on there, then, who knows what else they can drop, the whole trick bot to Ryuk and all that fun. As far as I'm aware, they don't.
But, and Brandon, I guess you can expand on this, but I think the key is if we found in the wild that a dropper is using SMB, we could chain that against everything else we've written for Emote and supply that test, right?
Absolutely. Yeah, so as the threat evolves, like for instance, we at some point, again, we're trying to get the bases down. So here's all the base start of all the malwares, right? Once we get that, then we can start chaining those together. So if we get one for Quackbot, if we get one for TrickBot, for all these others that get dropped as a secondary payload, we can start to correlate that based on intel of we know Emote drops XYZ. So we'll go create a test and say, okay, if you want to emulate this, this chain, you can do that. Absolutely. Okay, so I know I'm going to be I'm going to try to get through this as much as I can. So I apologize if I rush a little bit. But when we start developing atomics, the big thing is what's the end goal? Are we trying to educate analysts? Are we trying to test controls? Or are we trying to test threat-specific stuff? So that's the difference between emulation and test. Is the emulation is going to be more the latter side. Do we want analysts to be able to see what they're doing, what they're actually supposed to be finding? Or do we want to see, okay, cool, this EDR caught this TTP. It works, right? There's some fantastic tools. One that was just recently published that you can use the framework to go grab all of the TTPs for an associated attack group, run them all. That's what's wonderful for testing various different aspects of your environment to make sure your protections are working right. Ours are more focused towards emulation and specific threats that we want to get in there. So we'll go ahead and dig in a little bit to the back end of how we're piecing this all together. So I'll start with the most simple one, which is our Emote encoded commands. I touched on it briefly on what we're doing. So we're pretty much taking 1027. So we'll go ahead and go find that one real quick. 1027 and this one. Let's go ahead and close that. Go away. So we're utilizing this command, the execute encoded base 64 encoded command here. So it's a really simple, straightforward atomic test. It only requires one input. So all we're doing, and this is a great thing about Atomic Red Team as a framework, is we're overriding this input by providing it as an input parameter. So when we come back to Emote, you can see here we have PowerShell command. This is what we want to provide. And I will full-heartedly admit, anyone trying to write really complicated stuff, figuring out your escaping can be relatively difficult. So if you can't get it to run right, just keep working at it, and eventually you'll get the escaping right. And how we do that is we just provide any variable. It doesn't have to be named input vars. That's just what we chose. But it does have to follow this, is because we're creating it as a structure. So the bracket, this is the actual name of what we're trying to replace within 1027. So we're trying to replace this value with what we want. And then we put in the value of whatever we're trying to replace it with from our test. The only other thing you have to do is just tell invoke that's what you want to replace with. So like I said, this one's pretty straightforward and easy in terms of specifying Inputargs. And like I said, this is a great extension that allows us we can chain together 5 or 6 of these. So if we really wanted to, we could run the PowerShell and then a dropper, and then based off of what other tests are available, and just change the input arguments. Now there are cases where we have to create our, so this one is the invoke maldoc, I believe. Yeah. So this utilizes Red Canary's, Atomic Red Team's default, I apologize, invoke maldoc. So we just provide the various different inputs that they need for that particular test. So the Office version, the executable name we want, the download URL, so on and so forth. So again, and if we find that a test doesn't quite fit what we want, which is where we ended up in this last one, this one, as you can see, is going to be a lot more complicated because we're taking in a lot more data and a lot more customization. So we went and created our own chained custom within this particular TTP. So we need to be able to create an email. We need to be able, so we went and modified that invoke maldoc PowerShell script to allow us to create emails as well as all the documents. based off of what was already done. We committed this to 1566, so that way anyone else can use 1566 in the same way. So if we come back again, that's way down here at the bottom. 1566 001. There we go. So if we search for chained, of course not.
It's been going so smoothly.
Yes. There's always that one hiccup within a live demo. I think it's because it's in our repository. We haven't.
Yeah, you were in the default atomics directory.
That would be why. 1566. There we go. Okay. There it is. Okay. So what we did here was we created one, and this will eventually get published back to Atomic Red Team, so anyone can use this as to their will. So you can create an email, specify the sender, subject, all that stuff. You can create a maldoc, and it'll run a PowerShell encoded command. So it utilizes some of the pre-existing stuff, but you can see here we're pulling in our docfish, and we're invoking it, and then we're giving it all of these input parameters. So that's just what the PowerShell script takes in to run and do all this stuff. But again, this makes it so anyone else can go use it. Like if we want to emulate a different threat actor or a different malware, we can probably utilize this same test with different input parameters. And that's the whole idea. We want to make something generic that we can just throw a bunch of stuff into when we need to change like the sender or the subject, or even what the text is that goes within the document. That's even one of the input parameters here. If I come back to Emote. So, we can change the doc image. We can say that's the save path. Here's the email body. So here's what we actually say is the email body. So you can change all this stuff to whatever you want and create that. So I think we're pretty much towards the end here for Q&A. There was some more stuff I hope I get through, but happy to answer questions now, and any lingering questions, you can reach out to us and be happy to help you.
Hey, Brandon, can you throw up that last slide on the present?
Absolutely.
Yeah, we can also, whatever you didn't get through here today, we can sort of coordinate on the back end between you and me and try and figure out a way to put it up on a blog or something.
Absolutely, yeah.
And yeah, we're on the Atomic Slack channel, so if you have questions, you can reach out to us there as well. I think we're really excited to be working with that engineering team, as Brandon mentioned. We're going to try to collaborate and build some of this in, hopefully, as kind of out of the box in Evoke. And so hopefully in the next couple of weeks to months, we'll be able to contribute some of this that we've created into the actual Atomic repo as well. But yeah, if you have any questions, there's our information. Please feel free to reach out. Brandon, I don't know if you have anything else for the end of this. We'll wait for questions to kind of trickle in.
Yeah, we got a good question from Corky in the Atomic Red Team channel. It says, it's not strictly a technical question, but from your experience as a SOC working, in a security operations center, MSSP environment, how do you sell your value to higher ups? The example given here is CIO on the value of monitoring and hunting. And if the return on investment is not in line with their expectations, like, for example, if it's not finding enough like malicious behavior to justify the cost.
Yep. So I just had a conversation today with some of our guys internally. So threat hunting as an ROI, a lot of times you see the mean time detection is really high in organizations, right? And in order to drill down into that and lower that, you need to start proactively looking for those threat actors and the bad in your environment. So our whole process as an MSP when we came from Foreground is let's do that proactive threat hunting, right? Let's not wait for those security tools to alert us. let's go in and find the bad, find the malicious behaviors ahead of when something might actually trigger, right? So that's really how we try to sell the value of threat hunting and generally to those higher ups and those CISOs.
Yeah, and to what extent do you think like that sort of ad hoc threat hunting allows you to look for behavior that isn't really detectable, right? Like you can't, it's not feasible for you to build out detection for this behavior, but by doing ad hoc threat hunts, you may be able to find this stuff and ultimately, create less brittle detection that does work to find it.
Right. I mean, there's adversarial behaviors. I think MITRE's done a great job of encapsulating that, right, with the tactics and techniques. But those advanced threat actors, things that might, come out next week or the week after, they might use some of the same tactics and techniques. But I think as you start chaining those together, it's harder to detect in some environments, right? That's where I think sometimes anomaly detection, statistical analysis comes into play, but it's really that threat hunter understanding what that adversary is trying to do, understanding what potentially that environment looks like, what their visibility is, because everybody's unique, right? Alerting, you can build alerts to encapsulate a lot, but I think every environment's unique, right? So an actor might get in one way in your environment than they would in another. So I think understanding that environment, doing that threat hunting, being proactive is crucial to finding those types of alerts and events. Brandon, any other comments on that one? As you're building these tests, right? That's the whole point of these atomic tests, is to really emulate that type of activity.
Oh, I have a question for both of you guys before we close out here. Like, what is your kind of product timeline? That's a bad way to put it. In terms of like which commodity malware you're planning to sort of develop these chains for moving forward. Do you guys have like a plan, or are you just sort of adding them here and there?
We do have a plan. We grabbed a lot of malware for like our threat feedings and things like that to kind of focus on. It's about 20 or 25 that we will work to put out first, and then kind of as we're doing that, we'll probably take a look and see, doing the additional chaining in tandem with adding to that repository as well. So we definitely have a plan of trying to get more and more out as we start developing content for them.
I think a lot of the work up front was building the framework that Brandon showed today. Like you said, we can extend on that, but I think getting that framework and that base built will allow us to go tackle those other 25 commodity malware type threats.
Sounds great. I'm looking forward to it. If you guys need any help figuring out like which things are occurring most often to set up the list of commodity malware you might want to go after, feel free to contact us at Red Canary, and we can sort of tell you which threats we're seeing most often. We don't have any additional questions, so thanks guys for coming on. Great presentation. I really enjoyed it.
Thanks for everything. Appreciate it.
Thank you.